for certain, like,
The velocity motion, experimental observation, computation model. In this lab, I observed the motion of a real object moving at constant velocity, analyzed the motion using tracker, built a computational model using Newton's second law, and compared the model predictions to my experimental data. The purpose. For this purpose, we see we can record real-world constant velocity motion, extract position versus time data using tracker, build a computational model using Newton's second law, compare experimental models, compare experimental and model results, and evaluate assumptions and source errors. The purpose of this lab was to test whether constant velocity motion can be accurately modeled by setting the net force equal to zero using the momentum principle. Experimental setup. For us, we're using the object, the roller cart, as seen in the photo. Motion is a straight line across the camera view. The camera is fixed with no movement. We use a meter stick for calibration, and the video is imported to the tracker. I recorded this tracker or this cart using a straight line across the screen, and then once again, calibrated it in tracker. The tracker analysis and extracting position and time data. So we set the coordinate axis accurate, and we calibrated scaling using the meter stick. We tracked the object frame by frame, and exported the position x and time t.
yeah.
So in this, I defined x-axis and the direction of motion, and then after calibrating it for each moment, I extracted the data as seen right here on the x
I agree.
axis.
That's what I was saying. It's part of the structure. It's like alpha is not that related. It's like also
So observation observed position over time. So as you can see, it's basically linear. The slope is at a constant velocity for this one, about barometric curvature, which the situation is probably just due to human error and just the start of the pushing and then the stopping. And then this shows its velocity for the object. So the physics models and equations for this. So obviously, we're using Newton's second law of momentum principle, which is F net is equal to dp over dt, and p is equal to mv. And then once again, we set this to net force equal to zero, so it's a velocity constant, which is F net equal to zero. And then this is obviously causing position to change linearly with time. And yeah, for the glow script model, so we use a mass of 1 kilogram. Its initial position tracker is at those coordinates, and then its initial velocity from the slope is here, and its net force was 0, 0, 0, obviously. And then we numerically recorded the time, or the total time of 0.875 seconds. And because this obviously setting the net force go to 0, the velocity will remain constant throughout the simulation, position updated over time. And then obviously you can show the close script, which by clicking this. So here is the close script after adjusting it for our data. Just showing here it is. Time is 0.875. And then if we were to run this program, you can see it goes in a straight line with position over time, velocity over time in a straight. With here the deviations over each point.
Whatever factor you're trying, I'm not going to focus it too much. I'm just alpha generating.
So in the model output, obviously, you just saw, so the vision graph is linear due to the velocity graph being a derivative of position. And we said the velocity is going to be constant, meaning it'll be a straight line. And once again, this just proves that the velocity was constant for this equation. And yeah, position just went linear. So comparison, the model versus our observation. So obviously the slope is a little off, but and it's just the way their angle is in reverse. But I think there's just a slight deviation due to error, which once again is probably human error from just us pushing the cart to initially go. And I feel like this just shows a just like strong point of comparison that our assumptions are accurate as long as f net equals 0.
Wow. I'm trying to think, like, it's kind of like
assumption for the model, obviously. So we said net force equals 0. We're assuming there's no friction or air resistance to minimize calculations. Then the motion is purely in 1D, so there's no other dimensions involved, just on the x-axis, and that's constant mass. And then we're assuming accurate calibration for this. And then, so what does zero net force mean? Sorry. So zero net force doesn't mean there's no forces. It just means the forces are balanced. So this includes the push forward, the friction, the normal force up, or the gravity down. These are all possible net forces, like a total out. As you can see on the right, you have, a force to the right, another force to the left, and then obviously you have normal and gravity against this object. Constant force be 0 without there actually being 0 forces. Now, for possible sources of error during this lab, obviously the camera, I was holding it like above, so I could have, we say it's not moving, but I may be shaking slightly during the filming. The calibration may not be accurate. Obviously, rotation and frame rate, I think my phone is at 30 FPS. What's human tracking error, just how much do we, accurately put it down? There's obviously slight friction. We use the roller and our experiment to minimize that friction, as that was its main purpose of the roller compared to possible other ones like like a car 12 years up there for a ball. Yeah. So that helps minimize the friction for us, but they're obviously still slow. So in conclusion, so motion was constant velocity as seen on those graphs. And second law was fairly accurately, modeled in the motion. And the zero net force explains this linear position graph, as there was no change in velocity as we saw on the graph and the glow script, position went straight up and then velocity was just flat, showing constant. And once again, comparing the model to the experiment, I feel like we saw that both were relatively similar. And the only different it was due to human error, possibly, or just other assumptions such as those, maybe just like computer error in the coding on tracker. Yeah, thank you for watching.
No, no, they might all
On constant, like, this is my lab on constant.